Alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam May-June 2024, paper 43. Let's start it. Question 1. Name the process used to produce ammonia from nitrogen. Reaction between nitrogen and hydrogen to produce ammonia is in HEPA process. Produce lead from molten lead bromide. Of course, lead can be produced by electrolysis. To separate insoluble solid from a mixture of insoluble solid and solution, insoluble solid can be separated by filtration. Produce ethanol from ethene. This is the catalytic hydration of ethene with steam. It's an addition reaction, so the name of the process is catalytic addition. To identify components of mixture of soluble colored substances, soluble colored substance like ink, dyes, pigments can be separated by chromatography and also can be identified by chromatography according to their RF value. So the process is chromatography. Separate mixture of several liquids with different boiling points. The liquids can be separated by fractional distillation, which is a process depend on the difference in boiling points between the liquids in the mixture. Determine the volume of an acid required to neutralize a given volume of an alkali. The neutralization between acid and alkali is done by titration. Question 2. Complete the table. Here in the first column we have atom or ion. Then we have to complete number of protons, electrons, and neutrons. For the first one, copper, it has no charge. It is neutral, so it's an atom. Here is the proton number, which is the number of protons, and the mass number, which is the number of protons plus neutrons. Because copper is an atom, the number of protons equal to the number of electrons, so we have 29 electrons. And to calculate the number of neutrons, we will subtract the mass number minus the proton number, so we have 34 neutrons. The second one, chloride ion, it has 17 protons, and because it has one negative charge, so the number of protons will be less than the electron. We will have 18 electrons, one more electron than protons because we have one negative charge, and the number of neutrons will be 30. The last one, it has 30 protons, so we will go to the periodic table, check element number 30, the element that have 30 protons. It is zinc. Now the number of electrons is 28, so we have two more protons than electrons. That means we have positive charge, so it's zinc ion with +2 charge. The proton number is 30. Then to calculate the mass number, we will add the number of neutrons to the number of protons, 34 plus 30, so the mass number will be 64. And here we can complete the last element in the table. It's an ion, zinc +2, with a mass number 64 and proton number 30. Question 3. This question about elements and compound. Some properties of graphite, oxygen, and carbon monoxide are shown. We have the melting point, boiling point, and conduction of electricity when they are solid. Why graphite conduct electricity when it is solid? Graphite has mobile electrons that can move through the structure or can move through between the layers, so graphite can conduct electricity. Complete the dot and cross diagram for one molecule of oxygen. Show the outer shell electrons only. Oxygen is in group 6, so it has 6 outer shell electrons. Each oxygen atom will share 2 electrons to complete the outer shell to 8, so we will have 2 shared pairs of electrons between the 2 atoms, 2 electrons from each oxygen, and we have to complete the outer shell 8 electrons by drawing 2 lone pairs for each oxygen atom. So the first oxygen have 2 lone pairs and the second one also. Now each oxygen has 8 electrons in its outer shell. Deduce the physical state of carbon monoxide at -195. Use the data in the table. Here for carbon monoxide, the melting point is -199 and the boiling point is -191. So at -195, the carbon monoxide is a liquid because minus 195 is greater than the melting point. So carbon dioxide is melted at this temperature, but smaller than the boiling point. So it didn't boil, it is still a liquid. So our answer will be at minus 195, carbon monoxide is a liquid because minus 195 is between the melting point and the boiling point. Explain in terms of structure and bonding why graphite has much higher melting point than carbon monoxide. Graphite has a giant covalent structure with many strong covalent bonds, but carbon monoxide is a simple covalent molecule. It has weak intermolecular forces of attraction between the molecules, which of course need a little energy to break. Potassium reacts with chlorine to form potassium chloride. Write a simple equation for this reaction. Here potassium is K and chlorine is Cl2 because all elements in group 7 are diatomic, and the product will be potassium chloride. And after that we have to balance the equation by adding 2 in front of KCl and 2 in front of potassium. The equation is for 2 marks. Remember to balance the equation. Dilute aqueous solution of potassium chloride undergoes electrolysis. Oxygen produced at the anode. State what is meant by the term electrolysis. Electrolysis is the breakdown of ionic compound, either molten or aqueous, by the passage of electricity. Write an ionic half equation for the production of oxygen at the anode. Of course, we have aqueous solution of potassium chloride. So we have potassium ions, chloride ions, and we have H and OH ions from water because it is diluted. So OH ions will be attracted to the anode to produce oxygen gas, as the ionic equation for OH negative gives 1 oxygen, 2 molecules of water by losing 4 electrons. Question 4. Dinitrogen tetroxide N2O4 decomposes into nitrogen dioxide. The reaction is reversible. Dinitrogen tetroxide is a colorless gas and the nitrogen dioxide is a brown gas. A gas syringe contains mixture of the 2 gases and the gas syringe is sealed. When it reaches equilibrium, the color of the mixture is pale brown. Describe a reversible reaction at equilibrium in terms of the rate of the forward reaction and the rate of the reverse reaction. At equilibrium, the rate of the forward reaction and the rate of the reverse reaction are equal. The concentration of the reactant and product at equilibrium, the concentration of the reactant and product are constant or remains unchanged. The pressure of the mixture is increased, all other conditions stays the same. The mixture immediately turns darker brown before the position of equilibrium changes. So we will increase the pressure, but before any change in the equilibrium position, the mixture turns to be darker brown. Explain in terms of particles why the mixture immediately turns darker brown. So we have to explain according to what happened to the particles makes the color turns darker brown before the position of the equilibrium change. So the darker brown color is the color of nitrogen dioxide because dinitrogen tetroxide is colorless. So by increasing the pressure, we have the same number of nitrogen dioxide molecule which is brown in a smaller volume, and that's why the color appears to be darker. The temperature of the mixture increase, all other conditions stays the same, the mixture turns darker brown. State what can be deduced about the forward reaction from this information. If we increase the temperature, the mixture turns darker brown. And the darker brown color is the color of nitrogen dioxide, so it is the forward reaction. By increasing the temperature, the equilibrium shifted to the right side or to the forward side. That means the forward reaction is endothermic because endothermic reaction is favored by high temperature. So we can deduce that the forward reaction is endothermic. Sulfur is converted into sulfuric acid by a series of reactions. Sulfur dioxide and oxygen react to form sulfur trioxide. The reversible reaction reaches equilibrium. Here we have the reaction between sulfur dioxide and oxygen to form sulfur trioxide. Complete the table using only the words increase, decrease, or no change. What will happen to the rate of the forward reaction and to the yield of sulfur trioxide if we add a catalyst? Of course, catalyst will increase the rate of reaction, so the rate of the forward reaction will increase. About the equilibrium yield of sulfur trioxide, catalyst has no effect on the equilibrium yield because it increased both the forward and the backward reaction by the same amount or by the same value, so no change on the equilibrium yield. If we increase the pressure, what will be the effect on the rate of the forward reaction? Of course, increasing the pressure means that we have higher number of particles per unit volume, more frequent collisions, and this will increase the rate of reactions. How the pressure affect the yield of sulfur trioxide, we have to refer back to the equation, count the number of moles on each side. We have on the left side 3 moles and on the right side 2 moles. So if we increase the pressure, the equilibrium will be shifted to the side of less number of moles. That means it will be shifted, right? And this will increase the equilibrium yield of sulfur trioxide. So the yield will increase. Deduce the oxidation number of sulfur in S sulfur. Sulfur is an element with oxidation number 0. It has no charge. In sulfur trioxide is a molecule, and the molecules are neutral. So the oxidation number of oxygen is -2. We have 3 oxygens, so the total number, the total charge of the 3 oxygen will be -6. And because the total charge of the molecule is 0, so the charge of sulfur is +6. Because the overall charge of the molecule is 0, so +6 minus 6 equal to 0. The oxidation number of sulfur here in sulfur trioxide will be +6. Question 5. Barium sulfate is an insoluble salt and it is made by precipitation. Name 2 aqueous solutions that produce a precipitate of barium sulfate when they are mixed. The salt, the insoluble salt, barium sulfate, can be prepared by precipitation, which is mixing 2 solutions to form a precipitate. The 2 solutions that you will mix is a soluble barium salt, so we can choose barium nitrate or barium chloride, both are soluble, and soluble sulfate salt, we can choose sodium sulfate or potassium sulfate. So mixing 2 soluble salts to produce a precipitate of barium sulfate. Describe how to produce a pure sample of barium sulfate from the mixture after mixing the 2 solutions. After mixing, we have to filter the precipitate, then wash the residue with distilled water to remove any soluble impurities, of course, then dry between 2 filter papers. Then write the ionic equation for the precipitation reaction, which produce barium sulfate, include state symbol. So writing the ionic equation, I will write here the original equation, which is the reaction between barium nitrate and sodium sulfate to produce barium sulfate and 2 sodium nitrate. We have to remove the spectator ions from the 2 sides of equation. Spectator ions are the ions that remains in aqueous state without any change in the charge. So we have here sodium and nitrate ions remain the same aqueous with the same charge. So the equation, the ionic equation will be barium ions, which are aqueous, will react with sulfate ions, which is also aqueous, to produce the insoluble barium sulfate, and we will write it as solid. Here is the ionic equation for the precipitation reaction for formation of the salt barium sulfate. It is already written here, barium ions plus sulfate ion to form barium sulfate. Name the dilute acid and one other substance that react together to form copper sulfate. Of course, from the name of the salt, copper sulfate, we can know that the acid is sulfuric acid, and copper sulfate is soluble salt, so it can be prepared by using the excess method, where we will add excess copper oxide, or we can add excess copper hydroxide, or also copper carbonate. So we can add any of these substances to sulfuric acid to prepare copper sulfate. Nitrate decompose when they are heated. When hydrated copper to nitrate is heated, oxygen gas is produced. Describe a test for oxygen. The test is glowing splint, and the observation, the splint will relight. Complete the equation for the decomposition of hydrated copper nitrate. First, we have to know that this 2 in front of the molecule is multiplied by the whole molecule, so we have 2 copper. And for nitrogen, we have 2 nitrogen times 2, so it will be 4 nitrogen. For oxygen, here we have 2 times 3 is 6, and multiplied by the 2 in front of the molecule, so we have 12 oxygen. And for hydrogen, 3 times 2 is 6, again multiplied by 2 in the front of the molecule, so it will be 12 hydrogen. We have another oxygen here, 3 oxygen times 2, it will be 6 oxygen, so the total oxygen on the left side will be 18. So to balance the equation, we will add 2 in front of copper oxide because we have 2 here, and 4 in front of nitrogen dioxide because we have 4 nitrogen here. And to balance hydrogen, to make hydrogen 12, we will add 6 in front of hydrogen. Now let's count oxygen on the right side. 2 oxygen in copper sulfate plus 4 times 2 is 8 oxygen in nitrogen dioxide, another 2 here, then 6 oxygen. Total oxygen on the right side will be 18. Now the equation is balanced. 2 copper oxide, 4 nitrogen dioxide, oxygen plus 6 water. Hydrated zinc sulfate gives off water when it is heated. Here we have the formula of the hydrated zinc sulfate. It is heated to give anhydrous zinc sulfate plus water. A student does an experiment to determine the value of X in the hydrated crystal. First, the student weighs a sample of the hydrated zinc sulfate, then heats the sample. The student weighs the solid remains after heating. Then the student repeats step 2 and step 3 until the mass after heat is constant. Why the student does step 4? Step 4, which is repeating, weighing and heating, the student does this step 4 to ensure that all the water is given off. In experiment, we have 0.574 grams of the hydrated zinc sulfate is heated until the mass is constant, and the mass of the anhydrous salt remaining is 0.322 grams. Determine the value of X using the following steps. First, we will calculate the number of moles of the zinc sulfate remaining. Number of moles of zinc sulfate, which is anhydrous, is the mass dividing the MR of zinc sulfate, which is 166. So the number of moles will be 0.002 moles. Then the mass of water given off, which will be obtained by subtracting the mass of the hydrated salt minus the mass of the anhydrous salt. So the mass of water will be 0.252 grams. Then we have to calculate the number of moles of water by dividing the mass of water by the MR of water, which is 18. So now we have the number of moles of water, which is 0.014. The number of moles of water, then we'll divide the number of moles of zinc sulfate to get the value of X. So X will be 7. This question is about iron. Figure 6.1 shows the blast furnace used to extract iron from its ore. Name the main ore of iron that is used in the blast furnace. The iron ore is hematite. Name the substance that entered the blast furnace at A. Here, hot air is introduced, so the name of the substance is air or hot air. Name the reducing agent in the extraction of iron in the blast furnace. Reducing agent is carbon monoxide. Explain why limestone is added to the blast furnace. Give details of the chemical reaction that are involved. Limestone is added in the blast furnace because they are thermally decomposed due to the high temperature in the blast furnace to form calcium oxide and carbon dioxide. Calcium oxide produced react with silicon 4 oxide, which is the impurity present in the hematite, to form slag, which is chemically named calcium silicate. So the calcium oxide, because it's a basic oxide, react with acidic oxide silicon 4 oxide to form slag, and this is how we can use limestone to remove impurities from hematite. The list shows properties of some elements: act as catalyst, have low density, low melting point, form acidic or form basic oxide, form colored compounds, form positive or negative ions. Iron is a transition metal. Sodium is group 1 metal. State which property from the list is true for sodium but not true for iron. Here we want one property, so we can choose any of that. Sodium has low density or low melting point. These two properties is true for sodium but not true for iron. Another property which is true for iron but not for sodium: iron is a transition metal, so it can be used as a catalyst and it forms colored compounds. A property which is true for both sodium and iron: both form basic oxides, or we can say that both form positive ions. Here he also wants one property which is not true for sodium and not true for iron. We can choose either they form acidic oxide or form negative ions. These two properties are not true for iron or for sodium. Steel consists mainly of iron. Iron rusts when it reacts with oxygen and water. Show in figure 6.2 shows magnesium blocks attached to the bottom of steel boat. The magnesium doesn't completely cover the steel. Magnesium blocks provide sacrificial protection for the steel. Why? You have to explain why in terms of electrons, why magnesium is used for sacrificial protection of the iron steel in the boat. Magnesium is more reactive than iron, so magnesium will lose electrons in preference to iron. That's why magnesium is used for sacrificial protection. Name a metal that cannot provide sacrificial protection. For steel, the metal cannot provide, of course, it is less reactive than steel, so we can use copper or silver because they are less reactive than iron, so they cannot protect iron from rusting. Question 7. Many organic compounds contain carbon and hydrogen only. An organic compound A has the following composition by mass: 83.33% carbon and 16.67 hydrogen. So let's calculate the empirical formula for compound A. We will divide the mass of carbon by the relative atomic mass, which is 12, and for hydrogen we will divide it by the mass of hydrogen, which is 1. So we will get a ratio for 6.94 carbon and 16.67 for hydrogen. We will divide by the smallest number, which is 6.94, so the ratio will be 1 to 2.4. To get a whole number ratio, we will multiply by 5 to convert 2.4 into 12, so the ratio will be 5 to 12. That means we have 5 carbon and 12 hydrogens. Then compound B has an empirical formula C2H5 and a relative molecular mass of 85. Determine the molecular formula of compound B. First, we will calculate the mass of the empirical formula. So C2H5 will be 2 multiplied by 12 for carbon and plus 5 for hydrogen. So the mass of the empirical formula will be 29. From the mass of the molecular formula, which is 58, divide the empirical formula, you will get 2. That means the molecular formula is double the empirical formula. So compound B is C4H10. Figure 7.1 shows a section of polymer formed from an alkene. Identify the function group in alkene that react when alkene form polymers. Of course, the function group is the double bond, carbon-carbon double bond. Here we have a section of a polymer shown in figure 7.1. Draw the displayed formula of the monomers that forms this part. Here we have the part in the box. This is the monomer, and we want to draw a displayed formula for the monomer. First, we will remove the open end, and we will add double bond between the two carbons, and we will number this as 1 and this as 2. So carbon number 1 have 2 hydrogens, this one hydrogen, the second hydrogen. Carbon number 2 have hydrogen and C2H5, so we will add the hydrogen, and the C2H5 will be drawn displayed formula as CH2CH3. So let's name this compound. Here we have carbon 1, 2, 3, 4, and the double bond on carbon number 1, so it is but1ene. Alkenes are produced by cracking alkane. When C12H26 is cracked, the products are ethene and an alkane, which form in a ratio 2:1 mole ratio. So we have ratio of the ethene to the alkane 2:1. 2 ethene molecule for 1 alkane molecule. So we will first write 2 ethene molecules, and then we will count how many carbon and many hydrogen left. In 2 ethene molecules, we have 4 carbons and 8 hydrogens. So out of 12 carbons, we will have 8 carbons left. Then from the 26 hydrogen, we will remove 8, so we have 18 hydrogen left. So when C12H26 cracked, it will produce 2 ethene molecule and 1 C8H18. State the general formula of alcohol. The general formula CnH2n plus 1 OH. Draw the displayed formula of one alcohol with a molecular formula C3H8O. Name the alcohol you have drawn. Of course, we will draw an alcohol with 3 carbons. Here is carbon number 1, carbon number 2, and carbon number 3. So the 3 carbons will have 7 hydrogens and 1 OH group. So now we have 8 hydrogen and 1 oxygen. We can put the OH group, which is a function group of alcohol, in carbon number 1 or in carbon number 2. So we can draw either propane 1-ol or propane 2-ol. Both are correct. Here we come to the end of our exam. Like the video and subscribe to the channel to receive all the updates. Comment down below if you have any questions. Thank you for watching. Wish you all best of luck.